Once again, welcome back to my YouTube channel. I am Pavni Raj from Sri Venkateswara College of Engineering. So today in this section, we are going to discuss on how HTTP works and the role of a client-server architecture in the web. So let us go for the introduction part to HTTP and the client-server architecture. HTTP, it is a hypertext transfer protocol and is the foundation of data communication on the web. Hence, the client-server architecture is a model for structuring network applications. So together, they enable the seamless interactions between users and web resources. What is HTTP? An HTTP is an application protocol used for transmitting hypertext over the internet. Hence, it divides how messages are formulated and transmitted between clients and the server. Hence, the protocol operates on a request-response model facilitating communication. So, the client-server model. The client-server model divides the tasks between services providers and service requesters. Hence, clients initiate requests for resources while server respond with the requested data. Hence, this architecture allows for scalability and efficient resource management. So let us know how HTTP request works. Hence, a client sends an HTTP request to a server for a specific resource. Hence, the request includes methods such as GET, POST, PUT, and DELETE. Hence, each method defines the action of the client wants the server to perform. So HTTP response mechanism. After processing the request, the server sends back to an HTTP response. Hence, the response contains a status code indicating the outcome of the request. The body of the response typically includes the requested data or an error message. HTTP methods overview. Hence, HTTP defines several methods for different operations on the web resources. The most common methods are get, retrieve, and post submit data. Other methods like put and delete allow for updating and removing the resources. Understanding the HTTP status codes. Hence, HTTP status codes indicate the result of the server's processing of a request. Codes are categorized into 5 classes. Those are informational, success, redirection, client error, and the server error. So common codes includes 200, 404, not found, and 500, internal server error. The role of URLs in HTTP. Hence, URLs is known as the Uniform Resource Locators. Specify the address of resource on the web. Hence, they consist of several components such as protocol, domain, path, and query parameters. Hence, the client uses the URL to identify what resources it seeks from the server. The importance of headers. Hence, HTTP headers provides essential metadata about the request and response. They can include information like content type, authentication tokens, and caching directives. Headers play a crucial role in ensuring proper communication between client and a server. The concept of statelessness is HTTP is a stateless protocol, meaning each request is independent. The server does not retain information about the past from the clients. Hence, this design specifies the server management but requires additional mechanisms for session handling. Persistent connection in HTTP. Hence, HTTP 1.1 introduced persistent connections to allow multiple requests on a single connection. This reduces the latency and improves the performance by minimizing the overhead and establishing the connections. Persistent connections are crucial for modern web applications with many resources. Introduction to HTTP2. HTTP2 is a major revision of HTTP, enhancing performance and efficiency. It introduces the features like multiplexing, header compression, and prioritization of requests. These improvements allow for faster loading times and better resource management. Security in HTTP. HTTP can be secured through HTTPS, which adds a layer of encryption. HTTPS uses SSL or TLS protocols to protect data transmitted between client and server. Securing HTTP is a vital this security HTTP is vital for safeguarding sensitive information such as passwords and credit cards numbers. Then the role of a web servers. The web servers store and serve web contents to clients upon request, and they process incoming HTTP requests and deliver the appropriate responses. Its popular web services includes Apache, Nginx, and Microsoft IS. The role of web clients. Web clients such as browsers and applications initiate requests for web resources. They interpret and render the data received from servers for user interactions. Its popular web clients includes Google Chrome, Mozilla Firefox, and Safari. Caching mechanisms in HTTP. Caching improves performance by storing the copies of resources for quick access. Hence, HTTP readers like cache control and expides dictate caching behavior. Effective caching reduces server load and enhances user experience. Load balancing in client-server architecture. Hence, load balancing distributes incoming requests across multiple servers. Hence, this ensures no single server becomes a bottleneck, improving reliability and performance. Hence, global balancers can also provide a redundancy in case of server failures. Scalability of client-server architecture. The client-server architecture allows for a horizontal and vertical scaling. This horizontal scaling involves adding more servers to handle increased load, and the vertical scaling means upgrading the existing servers to boost their capacity. Future trends in HTTP and the client-server architecture. The evolution of web technologies is leading to a new protocols like QoIC. Serverless architectures are gaining popularity, shifting responsibilities from servers to cloud services. These trends aim to further enhance speed, security, and scalability in web communications. And the final part will be the conclusion. HTTP and the client-server architecture form the backbone of a web communication, and understanding their workings helps in developing an efficient web applications. As the technology evolves, so do the protocols and architectures that supports the web. Thank you.